Hey there y'all, today we're going to look at 4.2 on slope and rate of change. In this lesson, we're going to look at how to find the slope given 2 points and find the rate of change of an applied problem. This all falls under the standard of FIF 7 and mainly dealing of functions that are increasing, decreasing, positive or negative. And so we're first going to talk about the slope formula. And this is something that you should remember from middle school, but the slope formula, m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, you might have seen it also written as m equals y sub 1 minus y sub 2 over x sub 1 minus x sub 2. That's fine. The key is this, that the y's are in the numerator and the x's are in the denominator. That is the key. And also that our 1's are lined up vertically and our 2's are lined up vertically. Same over here. The 2's are lined up first and then the 1's together. And so you might also have seen it written this way. M is equal to the change in y over the change in x. And that little triangle symbol, it's the Greek letter delta, and it means the change of or the change in. And one last way you may have seen this written is as the rise over the run. And remember, rise is how far we're going up or down. Run is how far we're going left or right. And remember that if I'm going up, I'm going more positive. And if I'm going down, I'm going towards negatives. And same with left and right. Left is negative, right is positive. And so when we look at the final answer, we want to know where we're going. Okay? So let's look at a couple of examples on finding slope. So in example 1, we're going to look at how to find the slope between negative 2, 5 and 4, 6. And so we're going to first write our slope formula. So m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And when we look at these ordered pairs, we want to label them. Remember that ordered pairs are always in the order x, then y. So x, y, right? Now, where do the 1's and 2's come in? Well, this is the first order pair, so it's x sub 1, y sub 1. That's the only reason we have the 1's there. And then this is the second order pair, so x sub 2, y sub 2. And just understand that these are written below the letter, not above. These are not exponents, so don't think that you're raising something to a power or something. These are subscripts. They're just labels. They don't do anything to it. So let's continue on. So y sub 2 is 6 minus our y sub 1, which is 5, over x sub 2, which is 4, minus negative 2. So we're going to get 1 over 4 plus 2, which gives us 1 over 6. So the slope of the line between negative 2, 5 and 4, 6 is 1, 6. And we're done. We don't need to convert that to a decimal unless we're dealing with like money or distance. We're going to leave it as a fraction in our problem. Let's look at example B. In example B here, we see that we're trying to find the slope between 1/2, 4, and 6 and 2/3. So here we've got a couple fractions involved. And understand that the difference between middle school finding slope and high school finding slope is that we deal with fractions in these problems. So let's talk through how we deal with the fractions in it. So we're still going to write our slope formula first. So m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So this is my x sub 1, y sub 1, x sub 2, y sub 2. And so we're going to fill everything in. So we get 2/3 minus 4 over 6 minus 1/2. Now, we got to remember that we're subtracting fractions here. And to subtract fractions, we need a common denominator. And so the 4 will become over 1. And then we'll convert that to a common denominator. And so what that's going to give us is 3. Now, the 2/3 didn't change, but this did. So the 4 over 1's will become what over 3? Well, we multiply both those by 3, we get 12. And so what we're going to get, now you see I'm only working the numerator at the moment. We'll get to the denominator in a minute. What is 2/3 minus 12/3? It is negative 10/3. We're going to pause the numerator there and we'll come back to it in a minute. Now let's work the denominator. We've got 6 minus 1/2, so that's going to be 6 over 1 minus 1/2. So that is 12 over 2 minus a half with our common denominators. And 12 minus 1 is 11, so I'm going to get 11 halves. Now, we have a fraction divided by a fraction. And remember that fraction bar in the middle is division. So we can rewrite this problem as negative 10 over 3 divided by 11 over 2. But remember that when you divide fractions, you're really multiplying by the reciprocal. So we're going to keep the negative 10 thirds. We're going to make it multiplication, and we're going to take the reciprocal of the second fraction. So 2 over 11. And so negative 10 times 2 is negative 20, and 3 times 11 is 33. So the slope of the line between 1/2 4 and 6, 2/3 is negative 20 over 33. That's it. Again, it's a little messy sometimes, but you've just got to deal with those fractions and deal with getting common denominators for your numerators and common denominators for your denominators wherever you have fractions involved. So let's look at example C. In example C, we're looking at a table here instead of a pair of ordered pairs. But remember that in a table, these are just ordered pairs. So negative 2 pairs with the 5, right? 0 pairs with the negative 3, so on. And so if I'm looking at a line, which it tells us it's a line in this problem, right? If we're looking at a line, the slope is the same no matter where it is along the line. So I can choose any two of these ordered pairs to use for the slope formula. And so I'm always going to choose stuff that makes it easiest to plug in. Zeros, ones, small numbers, right? So I'm going to choose this as my first order pair. So this is going to be my x sub 1, y sub 1. And I'm going to choose this as my second order pair. So x sub 2, y sub 2. And so m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So m is equal to negative 7 minus negative 3 over 1 minus 0. The double negative here becomes positive. So negative 7 plus 3, 1 minus 0 is 1. So this is negative 4 over 1, which is just negative 4. So the slope of this line represented by this table is negative 4. Now, I could do it with two other order pairs. I could do it with the negative 2, 5 and the 3, negative 15. If this is truly a line, the slope will be the same for all of these combinations. It doesn't matter which two I choose. The slope will always reduce to negative 4 for this line. Okay, so that's what we're looking at there. So now that we've looked at slope just kind of on a graph, we're going to look at some rate of change problems and some word problems to see how this applies in real life. So in example 2a here, we see that a student weighed 105 pounds in the 9th grade and weighs 170 pounds their senior year. What was the rate of change in weight? Now, let me give you a little hint on how to figure out these units here and which order they're going to go in. Remember that slope we said was the change in y over the change in x. So these two variables that we have pounds and we have what grade they're in, right? So one of them is going to be our x variable, the other is going to be the y. So which order makes sense? That I have pounds per year or years per pound. Which one makes sense? Well, pounds per year makes a lot more sense than years per pound. So that's the order we're going to go with, meaning that my y are the pounds and my x is the years. So we're going to pull out the information from this problem. And so we've got 105 pounds in the 9th grade. So that's going to be written as an order pair. And remember we said that the pounds would be the y. So 9th grade, 9, 105 pounds. So 9, 105. And then we've got the second one. He weighs 170 pounds their senior year, or she. And so what is senior year? What grade is senior year? That is 12th grade, right? So our order pair here is 12, 170. And so we can label these out. X sub 1, y sub 1. X sub 2, y sub 2. And we write our slope formula. y2 minus y1 over x2 minus x1. So we're going to get 170 minus the 105 over 12 minus 9. So we're going to get 65 over 3. Now this will divide out, and this is going to be 21.6 repeating. But we had units involved here, right? What was our numerator unit? it was pounds, and our denominator was in years. So this is 21.6 repeating pounds per year. Now, this is a word problem, so it requires what? A word answer. So what is our word answer? It's that the student, they did what? They gained 21.6 pounds per year. Now, we can get a little bit more specific with our final statement that they gained 21.6 pounds per year between the 9th and 12th grade. That's not important right now, but that could be important in problems that we deal with later on. But for right now, the student gained what? 21.6 repeating pounds per year. If the problem asks you to round to a certain decimal place, then obviously round it to whatever place it tells you to. Okay? So let's look at our final example, example B. So in example B, we see that a bicyclist is on a ride. After an hour, she rode 17 miles, and after 6 hours, she rode 58 miles. What is the average rate of change? And so again, we're going to set up our x's and y's and understand what is our independent variable, the x, and which is the dependent, the y. Our first bit of information is that after an hour, she rode 17 miles. Now, you may be saying there's no number there for the hours. Well, an hour is how many hours? 1, right? So our first order pair, and we've got to decide the order here. Is hours the x or is miles the x? Which one's independent? Hours are independent. Time moves on no matter what, right? So when we think about our change in y over change in x, it's going to be the number of miles over the number of hours. And so I'm going to have 1 hour, 17 miles. Our second piece of information, 6 hours, 58 miles. And so on that one, 6, 58. And so x sub 1, y sub 1, x sub 2, y sub 2. M is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And so y sub 2 is 58 minus the 17. 6 minus 1. So 58 minus 17 is 41. 6 minus 1 is 5. And so this will divide out to 8.2. 8.2 what? Our units were in what? Miles per hour. And so the bicyclist rode at an average rate of 8.2 miles per hour. That's our statement again. So remember that word problems require what? Word answers. This is our word answer. All right, that is it for section 2. I hope y'all have a great one, and I'll catch y'all next time.